these problems. I don't think it's this one. I think it's actually the one we did yesterday. But I'm going to suggest that unless you're told otherwise, that maybe when you do this, jump in to do the law of cosine, that you start with the biggest angle first. I think that might fix the problem. You don't understand why there's an issue, but there is. We have to figure that out. But I think if we start with the biggest angle, I think we'll be fine. So which one will be the biggest angle? B. And I'm not suggesting that just for this problem, because I think this problem's going to be weird on its own. But just in general, if you're finding the angles, if you have no angles of the triangle, you're going to jump in, use law cosines, start with the big one first, and go from there, and everything will work out. So B's the big angle. So that means that when I set up my law cosines, out here on this end, I'm going to have cosine B. And on the other end, I'm going to have 16 squared. Do you remember that about the law of cosines? That whatever angle you're using, the angle and its side bookend the problem. And then, in the middle of all that, will be a combination of the 10 and the 4. So 4 squared plus 10 squared minus 2 times 10 times 4. That's the way the law of cosines works. We have side squared and cosine of that angle over here. And then in the middle are the other two sides squared and added up, and then minus 2 times the product of those two sides. These are the ones you have to be careful when you type it in, because too often we kind of get going on our calculator and we type all that in. You cannot. You cannot. Can we type this in and add those together? Yeah, that would be fine. So 256, and that would be what, 116? And then you can type these together. You can do that, and that would be what, 80 cosine B? But don't combine the 116 and the 80. That's, you can't do that. So what are we gonna do? If we can't do that, what are we gonna do? Subtract the 116, so let's see. I hope my arithmetic's right. Is that okay? And then divide by negative 80. And then second cosine. What happened? Error. You got an error. You got an error. Now, I want you to look carefully at this triangle.
Yeah.
And tell me why we got an error. Look at the triangle itself and tell me why we got an error. Finley?
Do the two sides have to add up to make it 16?
Bingo. Remember, two sides of a triangle have to add up to be more than the third side? Think about it, kids. Think about it. Is it possible to have a 4 and a 10 and then have the other side be 16? No, because if you laid the 4 and the 10 down like this, flat, they still don't make 16, right? So there's no way that other side can be 16. So right from the beginning, you might have noticed this triangle is not possible. But all the stuff you learned in geometry is borne out in trigonometry. The calculator says, law of cosine says, this is not possible.
Why do you want to start in with the biggest angle?
Because, believe it or not, and you don't understand why, because that's a side situation, but if you start, as long as you use the law of cosines to find all the angles, you're good. But if you do what we did yesterday, which is use the law of sines to find the second angle, for some reason, you can get two possible answers, but you shouldn't, because it's a side. So, I don't know, we talked this morning, and neither one of us can figure it out. I'm sure there's a reason for it. He's gonna research it and see. So anyhow, I think, just from practicing on my own, I think that as long as we start with the biggest one, we're good. That seems to remove the ambiguity. Okay, all right, next. Number 2, we're going to find the area of the triangle. Now, back again from geometry class, tell me how you found the area of triangles. You did 1/2 base times height. So,
Yeah, that's why it's both sides.
for us, I can literally use B, side B would be the base, that's side B, and the height. That's fact, that's true, that's wonderful, it'll work all the time. The problem is, just in our short experience, when I throw information about triangles at you, what do I normally give you? Angles and sides. Usually the altitude is not part of the given. You could always go find the altitude on your own, but we don't need to do that if we kind of examine the situation. Let's look at this triangle right here, this right triangle right here. Would you agree that the sine of A, angle A, is H over C? In this triangle right here, would you agree with that? So H is C sine A. If I solve for H, it's C sine A. If I were to take that and plug it in here, then my area becomes 1/2 B C sine A. And that is our new area formula. This one's gonna be really handy. We're gonna get 2 of them today, and they're both gonna be handy in their own situations. One of the fun things about pre-calculus is we're gonna learn like 8 ways to find area of triangles. So today we're getting our first 2 new ways of finding area. So 1/2 BC sine A. Notice, I use this triangle. Could I have used this one and done sine C equals H over A? The formula may have looked a little bit different, but what I want you to notice is, to find the area, it looks like I take half, 2 sides, times the sine of the angle between them. So I multiplied B times C and then sine A. That's how the formula works. I'd rather you not memorize the letters. I'd rather you memorize that area is 1/2 side times sine of included angle. 1/2 side, sine. 1/2 side times sine of included angle. That is a very handy formula. 1/2 side, sine of included angle. All right, let's look at this first problem here. Find the area of a regular octagon inscribed in a circle of radius 9. What? Okay, what's a regular octagon? 8 sides, all sides congruent, all angles congruent, right? What does inscribed in a circle mean? Yeah, so here's our circle. And I'm gonna put 8 little hash marks on my circle. And I'm gonna connect those hash marks. And will that be my regular octagon then? Inscribed in a circle? Now the only thing I know about the circle is that the radius is 9. So obviously I can draw in a whole bunch of radii, right? If I do that, then my octagon is split up into a bunch of triangles. And are all those triangles the same? So if I could find the area of one of those triangles, then I would just multiply by 8 and I'd have my answer.
And it's 45 degrees
What's 45 degrees?
each triangle.
Right here?
Inner angle.
How'd you know that, Sabrina?
5/8. I hate 3/6.
Exactly. These are all congruent, and there's 8 of them.
Yeah.
So 360 divided by 8 will give me that angle. Now take a look at what information you have. Don't you have 2 sides and the included angle? So the area of the triangle is 1/2 9 sine 45. Oh my gosh, that is so easy. So much easier than back in geometry class when you were dropping in perpendiculars and doing all kinds of craziness. This is so easy. So that's the area of the triangle. So the area of the octagon will just be 8 of those. So 1/2, oops, 1/2 times 89 times times 6. Did you get 229.10 units squared?
And use the alpha.
Area of a triangle, 1/2 side, sine of included angle. 1/2 side, sine of included angle. Easy.
That's fine.
Alright, let's look at another one. Now we got a triangle, and his sides are 13, 15, and 18. We're gonna find the area of that triangle. This one's not quite as easy. What seems to be missing? Yeah, if I'm gonna do this, I need 2 sides, which I have, but then I need the angle in between them, which I don't have. So I'm gonna find that angle using the law of cosines. And I'm gonna go with the biggest one, so I'm gonna find angle B again. You okay with that? Kids, it's not gonna make any difference on the area. Just let us get this sorted out before we do anything different. So we're just gonna find the biggest one. Here we go. So 18 squared equals 13 squared plus 15 squared minus 2 times 13 times 15 times the cosine of each. How does that look to everybody? I know yesterday was our first day with all our cosines, but that look okay? This is one you have to be careful when you type it in, so let's see if we can find angle B. Okay, no guarantees, but I got 79.66. Anybody else get that? No? Yes? Now, we're gonna try to avoid round off at all costs. So when I go to find the area of this triangle, since I found angle B, I'm gonna use these 2 sides, right? We always use the sides that create the angle. So the area is gonna be 1/2, 13, 15, sine of B, sine of angle B, but that's on my calculator. So I'm just gonna do 1/2 times 13 times 15 times sine, second answer. What'd you get for your area? 95?
0.92.
I'm gonna go ahead and write out a whole bunch here, you'll see why, but yeah, it would be a 0.92 if I were rounding it off. But I'm gonna go ahead and write out everything I have, because we're gonna do something here that is about the most slick thing you've ever seen in your life. One of the most slick things you've ever seen in your life. You wait and see. You wait and see. Tess?
you not use 18 as a side?
What did you say now? No, you can't use, no, when you find the area, it's 1/2 side, side, sine of included angle. So the minute I chose that angle, then I have to use these two sides.
So if you want to choose C, then you have to use these.
Yep, C would be 15 and 18, yep. Included angle means the angle between the sides. Okay? All right, now, hang on to your hats. Hang on to your hats. Prepare to be amazed. All right? I want you to type this in on your calculator. All right, so I want you to multiply those 4 random numbers together and take the square root of it. What happened? You got exactly the same thing. Isn't that amazing? So, I want you to think about it. What we did was not hard. There certainly wasn't anything hard about this stuff that we did. But wow, that's a lot faster, right? So let's talk about finding the area of a triangle using what's called Hero's formula or Heron's formula. So turn the page. Heron's formula is another way, it's called hero, he's my hero for sure, other people call him hero. This is another way of finding the area of a triangle. So the formula looks like this. Okay? Now, I bet you know what the little a, b, and c are. The little a, b, and c are the sides of the triangle. What? S is the semi-perimeter. Hero's formula is only used when you're given all 3 sides. Because if you know all 3 sides of the triangle, then obviously you know its perimeter. Semi-perimeter means half the perimeter. Like a semicircle is half the circle. Half the perimeter. So, what's the perimeter of my triangle? 46. So half of 46 is 23. Then take that 23 and subtract each side. So 23 minus 13 is 10. 23 minus 15, and 23 minus 18. That's Hero's formula, and it will find the area of any triangle where you know all 3 sides. Please don't use Hero's formula if you don't have all 3 sides, because think about this for a second. Let's say you did the law cosines or something, and you found this side was 5.72 or something. I'm making that up totally. Then suppose you said, okay, now I'm going to use Hero's formula. Do you see why that's not a good idea? Because that was rounded off, and how many times is that number used in the formula? It's used in every S, and it's used in whatever side it is. So that error, that round off error, just gets compounded. So only use Hero's formula if you know all 3 sides. If you don't know all 3 sides, then use 1/2 side, side, side. Okay? So cool. All right, number 4. Are you impressed?
That's very slick.
Very slick. All right, number 4, here we go. Number 4. Gotta find the area of this triangle. Or this shape, it's not a triangle, find the area of this shape.
Yeah.
All right. Now, I want you to think about something. Now, the unit on that centimeter, so this doesn't really apply. But what if the unit on that were meters? Think about this for a second. All of you live somewhere, right? Most of you live in houses that are on lots. And your parents pay property taxes based on the amount of property, land that they own. Somebody has figured out that your property is so many square feet or so much of an acre or whatever the unit is. My house actually sits on a very odd shaped lot. It's not exactly this shape, but some surveyor came out at some point and figured out the area of our lot. That's what you're doing right now. This is somebody's lot. You're gonna figure out the area of it. It is not a regular shape, so you're not gonna use one of your canned formulas. What are you gonna do? Do you have an idea? Split it up. If we split it up, we can actually split it two ways. We could split it long ways, or we could split it short ways. Both of them are going to work just fine. Both of them will give you the answer. Do you have a preference?
Yeah.
Sure. I do too, because if I split it this way, this triangle is a right triangle, and there are things I can do with right triangles that I can't do with other triangles. If I split it this way, then I'm gonna have two random weird triangles, and that's okay. I can still do the problem, but it may be a little more work than it is this way. So I'm gonna call this triangle 1. What is the area of triangle 1? The area of triangle 1 is 1/2 base times height, or you can do 60 times 70 times sine 90. Sine 90 is 1. It's base times height. So I'm just going to do 1/2 60 times 70. And that's the area of triangle 1. Did you get 20? Oh, I guess I could have done that in my head. Did you get 2100? All right, that's the easy one. Now we got to talk about the other triangle. Okay. Clearly not, we're not using hero on this, right? We don't know the sides. So we're going to probably use 1/2 side, side, sine, which means we need to know two sides and the angle in between them. All right, so let's look at it. Right now we have nothing except one side for this triangle. So do you have a thought? Pythagorean theorem. See, that's why we like our right triangles, right? We can use the Pythagorean theorem to find this side. So I'm just going to leave it as a radical to keep things not rounded. So I got the square root of 8,500. Is that what you got? Now, if you have these two sides, kids, ideally you will find this angle. I'll call it X. Because the area of triangle 2 will be 1/2 98 square root of 8,500 sine X. All right, how can we find X? Let's think about that for a second. X is not 108, you understand that, right? I split that 108, so, and it's not split in half. So what do you think, Tom?
Find the angle on top of triangle 1.
Oh, Dom says, let's find this guy, I'll call him Y. Because if we can find Y, we can do 108 minus Y to get our X. Now, how can we find Y?
Sine 90 over down to 195.
So I'm hearing sine y over 70 equals sine 90 over the square root of 8,500? Is that an option? I thought I heard that from someone. Is that okay? What's another option? Catherine's got her hand up back there.
You could do tangent of y just 70 or 60.
Remember, that's a right triangle. Law of sines is gonna work every time, but SOHCAHTOA works too, since it's a right triangle. So she says tan y equals 70 over 60. All right, do both. Let's just make sure that it works. You're gonna get the same answer. Tell me what you get for angle y. Everybody got 49 point something?
Yeah.
Okay, but remember, don't even write it down. No one cares about y. I mean, oh wait, is that what you got for y? That's what you got for y. Nobody cares about y. We want x. So take 108 minus your y, and what did you get for x? That's the important one.
58.6.
58.6? I'm taking it from the crowd, is that right?
Yeah.
So now, the area of that triangle will be 1/2 98 square root 8,500 times sine second answer, and you don't have to round off at all. What did you get for the area of triangle 2? Three, 8, 5, 5, 9, 8. 3, 8, 5, 5, 9, 8. Is that what everybody got? No?
Yeah, give me rounding. I got five.
Do you round it? What is it? 3, 8, 5, 6. Point what? 0, 3? All right. That's not what's. All right. What I want to point out here is, guys, you've got an answer button. The newer calculators actually allow you to actually copy and paste numbers. That's great. If you have an older calculator, just use your answer button. There really is no need to round anything off in this problem until you get to the answer, right? So I'm going to go through and do it just to make sure we got, I need the second tangent.
Someone else said it. I got that. I rounded that.
Oh, my total of
No.
5. Well, do you want to use that? Well,
Okay, so those of you that said this are right. That is the answer right there. Now, it is not the answer to the whole problem though, because this is the area of triangle 2. So we gotta go back and add, what was it, 2,100? So the area of the whole shebang is 5956.03 square centimeters. That's the area of the whole figure.
like on that, will round off error be like accounted when like
Yep.
your so it will be taken off
Yep.
where
Yep. Now, if there's a time when it just is so awkward to not round off, then it's okay. But here, there's no need to at all. Yeah. What did you feel the need to round off?
I think when I just subtracted them, I rounded. But I didn't get that. I got 3855.98 when I I didn't.
That's what he got because he rounded something up. So it caused an error, right? It's only 0.05, but it's still 0.05.
0.05?
Yeah. I think she said 0.98.
Oh, wait a minute, that's how much is that off?
Okay. All right, one more. Let's get one more done before we have to leave. Number 5. All right. Tony must find, oh wait, before you erase all this, moral of the story. We got a weird shape. Think about, right before this we did a octagon. We split our octagon up into triangles. We split our, whatever this is, up into triangles, right? That's your strategy. Try to split it up into triangles. All right, surveyor, find the distance from A to B on opposite sides of the lake. This is a real life problem. Real life problem. There's no way to measure it directly. So they're going to use our surveyor guide to come out here and it measures angles and all that. We want to find the length of AB. What is the length of AB? So take a look at it. This is an area. It's not an area problem. It just says what's the length of AB. So that's X. So take a look at it. We're finding a side of a triangle. That's either law sines or law cosines, one or the other. So which is this one? Gotta be cosines. Sarah and Tess, I hate to interrupt your conversation. Is there something you want to share with the rest of us? It's one of the coolest things you're going to do all day. All right, all sines or cosines, what did you say? Cosines. Because what do I not have? I don't have a pair. Every time you don't have a pair, it's not going to be a law sign. You can't do law signs. All right. So what's cosines going to look like? What? X squared. And then out here it's going to be cosine 78. Remember, whatever angle you're using, in this case you don't have a choice, that's your only angle, it bookends the problem. So you put cosine 78 out there, you're going to put x squared here, its side. And then all this in the middle is going to be a combination of 860 squared plus 175 squared minus 2 860, 175. That's the pattern for the law of cosines. Thank God for calculators. Remember, when old Mrs. Ford took this class, there were no calculators. We did this by hand. I know.
You're gonna look at it, it's all cleared out.
And you had
I
to look
always-
up
yeah,
because
I always
the
clear it out.
cosine 78 was in a table
all
and look,
cluttered.
you had to look it up. Oh, life was hard walking up there both ways. George, you're grinning from ear to ear. What'd you get?
No, it's just what you said, like Walker, no,
I'm a funny person, aren't I? I need an answer though, George. I'm gonna let you find it. Tell me what
841.
X is.
Is it 841?
841. And we'll put a unit on that. That is feet, 841.22 feet. And that is the answer to the problem. Okay? All right. So I'm kind of scoping things out. We should have all of our quizzes from all of our people who don't come to school and all that. We should have all of that made up. And so I am hoping to hand back quizzes.
Oh, wait.
I don't see this Wednesday.
Wednesday.
That's gonna be a long.
Would that be the next one?
June might be. Juniors, we have class tomorrow. Seniors, it will all be recorded. And seniors,